Alright, welcome to my newest LeetCode video where I go through seeing a problem for the very first time all the way through my whole process and solving it, all the way to getting the optimal solution. Today we will be doing a medium, so let's just get right into it. Dynamic layout, what's the difference between a normal one? I like that one, I think. It's all different. Oh, why is it all different? Alright. Why is the timer at 25 minutes? Ooh, it's all been updated. Alright, well let's reset the timer and we'll start it before we even start reading. Alright, let's go. 3, 2, 1, bang. So, 2150. Find all lonely numbers in the array. You are given an integer array nums. A number x is lonely when it appears only once, and no adjacent numbers, i.e. the number before it or after it, appear in the array. Return all lonely numbers in nums. You may return the answer in any order. So in this example, 10 and 8 look like lonely numbers because they only appear once, and 9 doesn't appear, 7 doesn't appear, and 11 doesn't appear. 6 and 5, they cancel each other out pretty much. Alrighty, 1, 3, 5, 3, the only numbers are 1 and 5. Alright, num's length can be pretty big, and so can the numbers, but that doesn't really, the size of the numbers doesn't really affect our efficiency needs, but the length of nums kind of does. So my first thoughts would be, well, we can do a brute force first, maybe, and just do, or actually, I was thinking maybe sorting it. Would an n log n algorithm be quick enough? Maybe, but let's just list a brute force, which would be for each number in nums, check if it occurs again or if x plus 1. For each number x plus 1 or x minus 1. If it occurs again or if x occurs. If not, add it to result vector. And that seems super simple. I don't see why that wouldn't work, but that seems like it would be a bit slow for these, because that would be n squared time complexity. Just put that in there. Now, we could keep a track of numbers we've seen once, but then we've also got to kind of keep a track of for each number if we've seen the number before it or after it. Alright, we could do that, which would be, what, 1 pass through? So we'll call that a 1 pass approach. Keep track of numbers we've seen for each number x in nums. Check if we've seen the number, if we've seen x plus 1 or x minus 1 before. If we haven't, now we want to add that to the result vector, but if we have seen it, we'll have to go back, and if we see it again later, we'll have to go remove it. Oh yeah, so wait. Now if we do that and we get to a number x and we haven't seen x plus 1 or x minus 1 before, then for now it's a lonely number, but then if we end up seeing it again, actually I'll try to write it down. If we haven't, add it to the result vector. If we have remove it from the result vector if it's in there, as well as x plus 1 x. So would that work? So for this example 10, 6, 5, we would go through 10, we haven't seen 10, 9 or 11, so we would add it. 6, we haven't seen 5, 6 or 7, so we would also add it to the result vector. Now 5, we haven't seen 4, 5, but we have seen 6, so we would have to remove, don't add 5, and we would have to remove 6 from the result vector. And now 8, we haven't seen 7, 8 or 9, so we would add 8. That looks like a pretty good way of doing it. Now what would the time complexity be? Sorry, this is also time complexity thingy. Space would also be n just for the result vector. This one would be time. Now it looks like we could do so for each number we have to check if we've seen it before, so we'd have to keep a, we could use something like a and then after either way add x to our storage of numbers we've seen, e.g. a hash map, which means for each number we'd see to look up x plus 1 or x minus 1 in the hash map, that would be big O of 1 time complexity, as lookup in a hash map is big O of 1 in the average case. So that would be big O of n, I think. Just with this result vector, it's a bit just a bit tricky if that's still big O of n or if that adds anything. Well, it's not going to be any worse than n, so I reckon it's big O of n, and space is also big O of n for the result and the hash map. So I think we're going to go for this approach, which is good. So only 7 minutes and we've got a good approach. So now we want to initialize our containers. So result. And then we'll use an unordered map, which is pretty much a hash map in C++, where let's see, the key is an integer and our value will be just a boolean, where true means we've seen it, just call it seen, where the boolean means we've seen it and the integer key is the number we're searching for. Now we iterate over nums. Oops. So for we can just do number in num just to be fancy. So integer number to nums, and now we want to check if we've seen it. Check if we've seen number. Okay, let me see if I can remember the right function. Is it something like contains or find? Find returns something. I know one of them. I'll do this for now, and if it's wrong, I'll try a few other things. If we've seen it, then let's think. Maybe if we haven't seen it yet, we would do well, we have to add it at least, which to do that you would do, what would you do? What's that function? I need to get used to using unordered maps. Scene, what's the function? I don't quite remember. Let's look it up just on c++.com. I definitely need to get used to using these containers, unordered map. I'm not sure if a set might be better or not, but we'll just use a map for now. So it's count. That's what it was. Did I use count? I use contain. That's also in there. But now, is it in place? Or is it insert? Looks like it would be insert in place. It seems to construct something. Insert only if its key is not equivalent. What's the difference between that and in place? They both seem to do a very similar thing. It's just that this constructs something which we don't really need. We use insert, that seems like the better thing. And does it just take in like number true? Is that how it works? We'll double check. Let's just check the example because that looks a bit confusing. Insert. Maybe you put it in like a list, I think. Seems to, I believe that's what that looks like. I don't want to spend too much time on that. So if we haven't seen it, if number not seen, add it to scene map. If we haven't seen it, and now we also want to check if we haven't seen number -1 and number +1. So that means we haven't seen number -1 or number +1, which means we can add it to result. So we can just push it back and do number. Whoops. If we haven't seen number -1, number +1, add it to result. But if we have seen number, then what would we do? Else do nothing unless number -1 or number +1 is in thingy. So else in this, I'm just trying to think if we need an else if just to be a bit more simple. I'm not trying to find something in a vector that might also be just need to iterate over it, or if there's a function. But we do else. Maybe I'm just trying to overcomplicate. You're still a nested if result dot, maybe it's find. I'm gonna have to look it up. This is definitely my weak point, knowing all the container functions. Otherwise, we're gonna have to iterate through them. So there's nothing to find. Maybe. No. We're gonna have to iterate through it, maybe. So else. So maybe there's another. Else check if number is in result vector. Number plus 1. If it is, we will remove it. So let's think. How do you remove it? Just erase. Hopefully that doesn't leave an empty space though. Just double check. There's definitely nothing to find. No, it doesn't look like it. No. Well, we would do for I can't call it number again. What's something we could call n in result if n equals number or n equals number minus 1 or n equals number plus 1. Then what we would do is erase n. So that just be result dot erase n. Hopefully. Now do you have to do anything else here? I don't think so. So then do just return result. If yes, erase result. Oh no, hold on. Is that an else? Or do we always have to do that? Oh, hold on, no, this is not good. Because oh dear, now I've just confused myself. That should be fine. But I'm just trying to think, is an else or do you do that anyway? No, it must be an else, right? Let's run it. 17 minutes for a not a bad looking approach. Integer. Whoops. Okay. Erase, we've used erase wrong. So how can we maybe get rid of that? We want to erase an element based on the value, not on the index. I think. Yes, I'm not sure if that's the best way. Clear clears everything, I'm pretty sure. So maybe actually we need the index. So if we just go in I is less than result.size I++. If that's all of these, it would be if result I equals number, then we want to erase, let me think, it would be result begin, is it just plus I? I'm gonna have to check. Dot result I did dot begin D, yeah. Which is the 6th element. I'm just trying to wait, so should it be plus I or plus I minus 1 or plus I minus 2? think so. We want to. I think it's just I. Oh, so that's supposed to say return. Hopefully. No. So we've got a 6 in there. That one looks like it works, but now what happens here? Is it anything to do with result.size changing? I'm not sure. I am curious what we've done. So I'm gonna. No, I don't want to resort to printing yet because you can't do that in an interview, can you? So that one seems to work. This one doesn't. This one keeps 6 in it for some reason. Yeah, maybe it's not the else then, because if we haven't, no, because if we haven't seen a number, oh no, but I'm not sure. Well, we'll get rid of the else just to test it. Just so it does both of them. See what happens. I don't think anything. No, yeah, that's gonna obviously remove everything. That's not correct. But I'm just trying to think. Thinky, think. Bless me. I equals 0. I'm just trying to think for this one. So why is 6 still in there? Let's run it just so we can see the test case. And let's go through an example. I should have done that, shouldn't I? So for this example, we just make a little comment down here. So first we are looking at 10. We haven't seen 10, so we would do 10, or we would do seen 10 equals true now because we haven't seen it, and result also equals 10. And then at 6, we're at 6, we haven't seen 6, so we get seen 6 equals true. We haven't seen 5 or 7 yet, so what we would do is we would do result equals 10, 6, and now we would do seen 5. We haven't seen that, so it's true. But now since so I think I see the issue, but let's go through this. We have seen 6, so we don't add it. But now 6 is still in there, so we have to remove 6. So maybe if I add something else in here? Yeah. Else the same thing, but without result equals number, because that's never going to happen as far as I can tell. Now, do we need this one? I'm not sure. So let's go through this example again. So seen 10 equals true, result equals 10. Seen 6 equals true, result equals 10, 6. Seen equals true, but since we have seen one of these, we check if it's in result, and 5 is in, so we remove it. So now result actually equals 10. Now seen, what's next? 8 was it? Yeah. 8. We haven't seen 8 yet, so we say true. And now result equals 10, 6, 8. That looks correct to me. I will submit that at 23. Well, not submit, I will run it. I hope I clicked run. And that seems to work. Let's submit it just to make sure. It could be a few tiny bits wrong, but maybe this will be good enough. I know it does a few things twice. And we've got a solution at 20... No, we haven't. I thought I was going to say solution. So time limit exceeded. It seems to be too slow. Now, I think... I'm just going to write that as a note. Inefficient solution at 24 minutes. I think maybe these two for loops are not very good. I'm just trying to think. Because we don't want to have to go through these for loops for every number. So, it just seems to be too slow. So how big's this? It's very big, yeah. So it can be massive. So where have we got some repeated work? I think we're pretty close to solving this, but not quite. If scene count equals else since we have scene number -1 we must move them results if they are in there. That's a very long-worded comment. Now for this one, do we need this one anymore? I think we do, because if we see another number, maybe it's just, we don't have to check. I don't think this is going to be fast enough still, because there's still like a loop, you know, what's the word? Nested loops a lot of the time. No. Is that better than we had? I don't know. Oh dear. Yeah, we got 8 more. So what's the issue here? Let's think. What's the issue? I mean, maybe actually, let me think. We could just add what we've, no, I was gonna, no, because that's gonna do the same issue. We could add the numbers we've seen to the hash map. Set them equal to true. And let me write that down. Add nums we've seen to hash map equals true. And for each, for each number do that. And if, no, I was going to say, like, if we see a number, no, I've just lost my train of thought on that one. So what are we missing here? I feel like these loops do not need to be there. There's got to be a better way of doing that. But we can't really do that every time, can we? Not really. So it's just too slow. That's the only issue. That's just too slow, which is difficult to deal with. We can do multiple run-throughs of nums if it's easier. Yeah, maybe if we do that. So add numbers in nums to hash map. That's just one run through, big O n time, and then after that we can look up if we've seen a number. Pretty easy. And then after that we iterate over nums if x plus 1, x minus 1 are in hash map, add them to result. That seems a bit too simple, but let's just try it, eh? So let's get rid of all this pretty much. Yeah, and now what we would do is we would do for int number nums again. Hopefully that's not confusing. Let me think. If same dot count number minus 1 and same dot count number plus 1, we will just do result dot push back. Now, would that work? Well, not for duplicates. So no, hold on. Duplicates will mess us up. So let me think. So if not seen, add it, else. How do you change the value? I don't quite remember. Is it just as simple as doing that? I think that's actually right. But now to check what scene number is, I'm not sure if this is the right way of doing it. No, hold on. So if duplicate set to false, let me see, and then if we x minus 1 and x plus 1 are not in nums in the map, and scene sort of like this. It's true, but now to access scene number, I know it's a different thing, so I'm not sure. But we can look that up. I hate to look it up because it means I don't remember it, which is not good. I remember it's not as simple as doing that, I think. Is it just that? Is it? Maybe it is. Is it really? Well, we'll try it. Scene dot number. I know it's like every second. So if it's true, then we would add it. Maybe let's run that. No, so yeah, this part doesn't work. Is it dot second maybe? I just remember there being a second. Maybe there's not even a second thing. So let's just get rid of that. And that works. Let's submit it. Hopefully that's quick enough. I don't see why it wouldn't be quick enough. It's big O of n. Yes, let's go 3417. Not best, but accepted that. 3417. I'm very happy with that. Oh, it even puts in a note down there. I love that. Oh, not too bad. We beat 50% on time and 73% on thingy. Oh, I'm very happy with that. So I almost got it pretty quick, but I just tried to overcomplicate it and do it all in one pass through of nums. Which, sure, if I managed that, I think it might be a bit quicker, but I messed it up, so it was slower. No editorial we can look at, which sucks. But let's look at some solutions, see if there's anything better. I can't think of a... No, there's definitely not an asymptotically faster solution. I don't think that'd be a... no, there wouldn't be an asymptotically more space efficient solution either, because you've got to put them in the vector at some point. C++ does that, does the same thing so far. And what's M? M is the map. Ooh, so they've done something a bit dodgy. Ah, I see what they've done. They've just done it equals 1 if they've seen it, maybe? Which means, yeah, so that's a very lightly coded one. Not lightly coded, but what's the word I'm looking for? A few lines, but the same approach pretty much there. Let's look at some more. Is that the one I clicked on? No. Oh yeah, space complexity is the number of unique elements, but in the worst case it would be every element in nums, so still n there. Pretty happy with that being the optimal solution. What the heck is a Garib approach? I'm not quite sure. I don't get what that's there for. Oh, it's just a weird way of doing it, just to save space, maybe, not sure. 2 lines, I'd like to see that. That's not 2 lines, that's 5 lines, buddy. Yeah. Funny man. Yeah, 100% I like to see that. Ooh, see? He did it in one, this guy, or person did it in one run through, which is very nice. Probably. I'm not sure why it's if I. Why do you need to know that I is valid? That's a bit confusing, but I like that. It's going to be quicker than the rest. Actually, let's study that a bit better, because it's important to know what's really quick. So that loops through nums. I'm not sure what the if I means. Does it just mean... I'm not sure. But if I is less than n minus 1, so does that just mean it's not the first or the last one? And then you check again that if nums, I take nums, the other one's more than 1. Oh, I see. If the difference... Oh, they sorted it. No, yeah, that's true. They sorted it. So that would actually be slower, because that's n log n when you sort it. So I'm not sure how that is 100%. Beats 100% time. That looks a bit dodgy, because they have to sort it. I like that solution though. That's what I was thinking of talking about, sorting it, and then you just have to find the difference between each number. That's simple, but not, I doubt that's 100% faster. It's a bit dodgy. Anyway, I think that was a good success. I'm aiming to get mediums to under 30 minutes, and if I tried not being so fancy, we could have done it. Anyway, thank you for watching this video. If you enjoyed it, definitely be sure to leave a like, comment any feedback you have. Definitely subscribe for more. It really means a lot and everything. Yep. Alright, I'll see you tomorrow. Alright, thank you.